Good morning, all you cool cats and kittens, and welcome to another episode of Science TV with Mr. C. I'm your host. Today we're going to work on a couple of different assignments. First, we're going to go to Orbit's assignment in the class on the calendar. So we're going to get started on that. As you open this document, you should see this worksheet here. Orbits, ellipses, and energies. In a swinging pendulum, we hopefully remember that potential energy is transferred back and forth to kinetic energy as it moves back and forth. The movement of planets and comets is a very similar relationship between them as well. We're going to read this passage, then we're going to examine the diagram below it and use the diagram to answer some questions. So let's begin. Planets and comets orbit the sun in ellipse-shaped paths. While they orbit the sun, they respond to the sun's gravitational pull. The farther away from the sun an object is, the less the gravity attracts it, and the slower the object moves. The energy of the comet is at its slowest position is similar to that of a pendulum at the very top of the swing. As the comet moves towards the sun, it gains speed until its closest approach to the sun is traveling at its maximum speed. The energy of a comet at this position is now similar to that of a pendulum at the bottom of its swing. And the comet moves past the swinging position as it moves further into space. The comet will follow the same orbit for many thousands of years, speeding up and slowing down and orbiting the sun many times. In this diagram we have below, it shows the orbit of a comet around the sun. Point A is where it's at its furthest from the sun, and point E is where it's closest. This comet is moving counterclockwise, as we can see by the letters B, C, D, E, F, G, and then back to A. It goes through this repeatedly for thousands of years. So our first question is, what point in its orbit does the comet have the greatest potential energy? And there's the second part, at what point does it have the least potential energy? Gravitational potential energy. Remember that if we have a book and we lift it high above our head, which is further from the source of gravity that's going to affect the planet, the higher we lift it, the more potential energy that it has. Using that knowledge, what point does this comet have the greatest potential energy? And then the opposite of that, where does it have the least? Use that information. You can also read back up here. It kind of gives some clues to the answer to that. When you are done with this, what you're going to do is you're going to go to Submit Assignment. You're going to write the answers. So for 1, you're going to write down at what point does it have the greatest potential, and then at what point does it have the least potential, and answer the remaining questions in the same manner. There are 6 of them here. When you finish with that, move on to the next part of the assignment, which we see on the calendar. Is a Newsella article, Energy Transformation. We can talk about how energy changes shape, changes forms. Remember, because of the law of conservation of energy, it can't be created or destroyed. So you're going to go to Newsella. I think this link will work. I'll take you there. You read a couple of paragraphs about it, and you're going to take a 4-question quiz. We've done this a few times. You can have the window open for the quiz. Take it while you're reading it if you like. You can take the quiz as many times as you want. Finally, it will keep your highest grade, so it's worth 4 points. It's up to you what your score is on this. And we'll go in the grade book however you want it. Our next assignment we have on the calendar is electrical energy outages. We've talked about many different forms of that energy. We've talked about gravitational energy, nuclear energy, chemical energy. Now we're going to start focusing on some electrical energy going forward. Electrical energy outages. You've probably all experienced this in your life. When the power goes out, when you're trying to watch your favorite YouTube video or play your video games. This is going to kind of explain what happens and how things get restored in those instances. An electrical energy outage is the loss of electric current to a home, business, neighborhood, or even an entire city. Electric current is fed into the homes and businesses with heavy-duty wires called lines. Some of them are above ground, some of them below ground. In this example we're given here, these lines are all above ground. Feeder lines deliver current to several thousand homes and businesses. So these lines here, where you see three of them going together, these are these high lines, these are called feeder lines. These feeder lines branch into primary lines. See right here, primary lines feed several houses, but not as many as these larger feeder lines. And then you get down to where we finally get into individual lines that go to homes and businesses. And they branch off these primary lines. So we look at this image here. An electrical energy outage can occur when any of those lines is damaged or broken. A tree falls into it, somebody slams into a pole and knocks it down, maybe it gets old, or ice is on it and breaks it. Anything can happen to these things. When that line is broke, there's an electrical outage. To repair the circuit, workers would first repair the feeder lines if it's broke on the feeder. This would restore current to many different houses. Next, the primary line would be repaired, and then finally the individual lines were repaired. Depending on where you are at in the circuit is how much priority they're going to put on your job. Again, we're going to answer these questions here. You're going to enter them into a text box, the submission form, all 4 questions. On Friday, I am planning on having a GEMKIT session, 2 of them, one at 10 o'clock and another one followed at 10:30. Hopefully I can see you there. If you have any questions, please send me an email or open up this chatter doc. That's all I have today. We'll talk to you later. Thanks for watching.